Good morning, this is Miss Billerbeck, and we're going to talk about 1.4 comparing exponents. So if we have a to the x equals a to the y, where a is greater than 0, which that means it's positive because it's greater than 0. And a can't equal 1 because then we'd have 1 to the 100 could equal 1 to the 2177th. Okay, so then these two would not be equal, so we have to have this condition here. So a cannot equal 1 because then a to the 100th is just 1, and this is just 1, so that doesn't make sense with this rule. So we have to rule out a equals 1. Okay, so if we have these conditions where a is not 1 and a is positive, then x equals y. So then this exponent has to equal that exponent. Pretty cool, huh? Okay, so let's do some examples. So we have this one. So let's do a prime factorization tree. So we're going to take 243 and see what we have. We want to get it in base 3. So we're going to take a 3 out, and that leaves us 81. We take another 3 out. We get 27. Another 3 out. We get 9. Another 3 out, and we get 3. So if we count the 3's, there's 1, 2, 3, 4, 5. So if we put this together, then 243 is 3 to the 5th. Well, if that's the case, and we had this rule says if that has the same base and they're equal, then x equals y. So that means x equals 5. And that's our answer. Okay, but what happens if we have this? Ooh, that's a mind blower. So we know that we have 3 to the x equals 1 over, and we know 243 is 3 to the 5. But how do we get 3 to the 5 on the other side of the fraction bar? How do we do that? Well, we just make it very unhappy. We put it where it doesn't want to be. So we put it right here, and then we make sure everybody knows it is not a happy exponent. It's very negative. Okay, so now we have the same bases, and we now know what x is. X is -5. Look at that. There is a reason why we have negative exponents, and this would be a good case for it. All right, let's look at another example. All right, well, let's prime factorize 16. I think most of you know what this one is. We're just going to keep taking some 2's out, right? Okay, so we have 2 to the 3x plus 1 equals 2 to the 4th. So we have the same base, so now we can say, well, 3x plus 1 equals 4, and then we start the sum process. So there's no simplifying, so the first thing we're going to do is an additive inverse. So the opposite of +1 is on -1. If we do it on one side, we do it on another. And that gives us 3x plus 0 equals, and then 3. So now we have one thing here, 3x equals 3. And we use a multiplicative inverse. So this is 3 multiplying x. What is the opposite of multiplying? That is right. It's division. So we divide both sides by 3. And that gives us x equals 1. So the answer to this is x equals 1. And we could see that there, 3 times 1 is 3, 3 plus 1 is 4, and that's what we were hoping for. Okay? Let's try the next one. So we have this one. So we need to break this 625 down, so let's do it. So we take that, we know it ends in 5, so it's divisible by 5. So we have 125. Okay. Yeah, 125. So then we take a 5 out of here, we get 25. Then we take another 5 out, and we get 5. So we have 5 to the 9 minus x equals, and that's 1, 2, 3, 4, so 5 to the 4th. They have the same base now, so we write 9 minus x equals 4. Well, we have 2 things here, 1 thing here. What's like 4? The 9. So the 9 gets moved over here. So we're going to use an additive inverse. The opposite of a positive 9 is a negative 9. So we're going to do a negative 9 here, negative 9 here. And we have x. That's a negative x. We can't drop that minus sign. And then 4 plus negative 9 is negative 5. Wait a second, I've got 2 negatives. I need to get rid of those negatives. So at this point, I can either multiply by negative 1 or I can divide by negative 1. Since you guys prefer multiplication, let's just multiply. So we're going to multiply by negative 1, multiply by negative 1, and that gives us x equals 5. So our answer to this is x equals 5. And if we check it, 9 minus 5 is 4, and that's what we wanted. So voila, that's what we're doing. So that is comparing exponents. Have a wonderful day. Bye-bye.